get familiar. So if you don't know by now, then you should probably get familiar.
Hi students, so in this video we will discuss the new concept that is called nuclear reaction cross section. Okay. Now let us see first of all how the nuclear reaction happens. As you know, the general equation in which a small x is considered as an incident particle and capital X is considered as a target. After the nuclear reaction we get the products called small y and capital Y. So small y is called actually the emitted or ejectile particle and capital Y is the final product. Okay. Now in this reaction, what is the role of the incident particle? The role of incident particle is to react with the target. Okay. So sometimes the entire incident particles may interact with the target to give the nuclear reaction, and sometimes some of the particles interact with the target to give the nuclear reaction. Some of the particles will just go out without any nuclear reaction. So that means you have to take a nuclear reaction in which how much of the nuclear reaction is happened. So as a measure, the quantity of the nuclear reaction is happened due to the incident particles in fact. Okay. Now we are considering that parameter as the nuclear reaction cross section, so that we can define the nuclear reaction cross section as the measure of the probability that a bombarding particle would interact with the target nucleus. Okay. So the probability quantity is measured as sigma, so called cross section. Now that quantity may be greater than pi r square or less than pi r square or equal to pi r square. What is that pi r square? Pi r square is the area of cross section of a nucleus present in the target. Okay, where r is the radius of the nucleus. So depending upon that we can have the total cross section happened in the nuclear reaction. Okay. Now how to estimate that total cross section in a nuclear reaction? So that we will calculate now by considering an example in which X is considered as a target in the form of a slab. Okay. Okay. Now in this slab, so A is considered as the slab area and n is small n is the number of atoms per unit volume and thickness of the slab is dx. Okay. And then area of cross section. Area of cross section. If area of cross section is A, then what is the cross section per atom? So for each nuclei we have cross section per atom is sigma. Okay. So that is mentioned here as a small area in the target. Now let us consider in the target how the nuclear reaction takes place when there are some incident particles. N number of incident particles are interacting with the entire slab. Let us say, so in which dn number of atoms, small amount of incident particles undergo interacting with the target and gives the nuclear reaction. Okay. So there are some of the incident particle will not undergo with the target nuclear reaction, so they just emit like that. So what is the total number of particles emerge from the slab without interaction with the target? So that must be n minus dn. Okay, so that is n minus dn. Not interacting with the nuclei, not giving any nuclear reaction. Okay, so that now we can calculate the probability of the nuclear reaction due to the incident particle. That is called actually the cross section, isn't it? Nuclear reaction cross section. Okay. Now what is the volume of the thin slab? We are considering it A into dx because A is area and dx is thickness. A into dx is the volume. Total number of target nuclei, you have to multiply number of atoms per meter cube to the above equation, that is n into A into dx. Okay. Next, total cross section of all the target nuclei. So you have to multiply sigma into Na into dx, where sigma is the cross section per atom. So total cross section of the entire target should be sigma into Na into dx. Correct. Next, then number of incident particles divided by total number of incident particle. Okay. So that is equal to what? Total number of interaction particle, that is with the target, that is dn. Okay. Divided by total number of incident particles, that is n, is equal to total cross section by target area. So total cross section is here. So sigma n into A into dx divided by what is the total available target area, that is A. Right. So from this equation we can calculate the cross section sigma. You can just cancel A. So left with sigma n into dx, isn't it? Therefore sigma is equal to what now? By cross multiplication, sigma is equal to dn by n divided by n into dx, isn't it? is the equation for nuclear reaction cross section. So we can measure the nuclear reaction cross section as in terms of just meter cube, same as the unit of area. Clear? Now look at the different types of cross sections. Okay, so we have total nuclear interaction cross section. So that is actually depending upon the kinetic energy and nature of the incident particle. So total number of particles which are interacting with the target nuclei gives actually the total nuclear reaction cross section. And the second one is partial cross section. So normally it happens when the scattering type of nuclear reaction takes place, right? So for example, if we consider total nuclear cross section is sigma total is equal to sum of sigma for scattered particles plus sigma of the observed particles. Then so this sigma of scattered particles and sigma of the observed particles can be considered as partial cross sections here. Okay, and similarly the third one is differential cross section. So this particular differential cross section gives the information about the angular distribution of the particles removed from the target after the nuclear reaction. Okay, so we can have the equation for that. Sigma of theta phi as a function of theta and phi is equal to d sigma of theta phi by d omega. So where this d omega is considered solid angle through which the emitted particles are making with the angle with the incident particles. Okay, so these are the different types of cross sections. Okay, clear? Thank you.